This is Geometry Lesson 7475, Parallel Lines and Proportional Parts Notes. To start off with, the notes say if a line is parallel to one side of a triangle and intersects the other two sides, then the sides have proportional relationships. So if you notice the picture over here, we can then say that AB is to BC as AD is to DE. Again, the sides have proportional relationships. AB is to BC as AD is to DE. Looking at example 1, we can say that 6 is to 4 on the left-hand side is to x minus 2 and 5. You're going to use cross products to solve. Please be aware of distribution, the distributive property from lower left to upper right, giving you 4x minus 8. Other side, 5 times 6 is 30. Adding 8 to both sides, of course, gives you 38. Divide by 4, you will get 9.5. Please be aware and comfortable with getting decimal answers. There's no issue with that. Use your calculators. Moving on to example 2, it says determine if BD and CE are parallel and explain why. So here's what you're going to do. You have nothing missing. There are no missing values. You have 14 is to 6 as 21 is to 9. What you're going to do is reduce those as far as you can, if you can, and you want to see and verify that you get the same answer both sides, which in this case you do. You divide both sides, the left side by 2, divide the right side by 3. They both reduce to 7 over 3. That checks out. If that checks out, that is the only verification you need to determine that you do have BD and CE being parallel segments. Moving on to the definition of mid-segment is, if you notice your picture here, the mid-segment is CD. That's what they're referring to, CD. Mid-segment is a segment that connects the midpoints of two sides of a triangle. And I'm going to pull out a little bit here so you can see the whole thing. It's also equal to 1/2 of the third side. So what that means is EC is equal to CA, ED is equal to DB, and furthermore, the third part is CD is half of AB. So there are your written out versions there, EC and CA, ED and DB, CD is half of AB. Moving then into example 3, has 2 parts to it. You're finding x and y. If you notice x right away, it's half of the third side, so half of 24 is 12. Easy enough. Then since you have the mid-segment breaking this into 2 equal parts, you simply set them equal to each other and solve. That is an easy solution there because you're going to subtract 2y from both sides and get y. Add 9 to the right-hand side and get 15. Moving on to the second part of your notes, gets a little more complex. If 2 triangles are similar, then their sides are proportional. Let's slow this down a little bit. If you notice in your notes, if you've printed them out or you're copying them from Canvas or the attachments in your emails, there are some things that are missing, so you want to fill those in with missing variables. So x and y on the left-hand figure for triangle ABC. I just called them randomly. AB is x and AC is y. You can use whatever letters you want to moving forward. So then what you're going to do is you notice they are proportional. So the 2 sides that you definitely have are 5 and 12. So that's a good start. So 5 is to 12 as x is to 37. So there's your first proportion. I did not circle cross multiplication. I'm assuming you guys can do that. If you need to circle them, that's fine. But you are going to cross multiply, then divide. So 12x equals 185, divide by 12, you get 15.4. Please be comfortable with getting decimal answers. I did round a lot of these. And then to revisit to find y, you're going to use the same proportion you did to find x. 5 is to 12 as y is to 35. So there's the second one right there you can see. Cross multiply, divide, you get 14.6. Please pay attention to the questions because it does say to find the perimeter of the triangle. So you're finding that the perimeter of this whole thing, you have x now, you have y, we just found it. We found those 2 things. you're going to add them all together. So don't forget that part. That's going to wrap up the question. So this plus this, right here, the perimeter of ABC, is 5 plus 15.4 plus 14.6. Luckily gives us a nice round 35. So that's even more of a reason to pay attention to rounding as you're getting each individual answer. Okay. Going to move on to example, the next one. I think it's numbered, the next example. This is a little more complex. I'm going to try to slow this down as well. If you notice what I did in this figure is I added 8 and 3 and got 21 because there are technically 2 triangles in this figure. You have the smaller one here. It is tucked inside the larger one here. And again, you do have missing parts. I filled those in with an X here and a Y here. The X is the easier one to find. That is simply based on 18 and 3 and 12 and X. Going up this side, going across this side. 18 is the smaller part, 3 is just this part of the larger. You don't have to do the whole larger triangle just yet, just this part of it. 18 is to 3 as 12 is to X. So there's that solution. 18 and 3, 12 and X. Cross multiply, divide, you get a simple 2. So that little thing right there is a 2. Now, going back to revisit the Y component, you have to make sure you're addressing the entirety of the large triangle. That is then why I did 18 and 3 and got 21. 21 is the entire left side because you're talking about the entire side here, which is why we'll bring this into it later when we do the perimeter. So now you also want to match up sides to find your proportion. So I did 18 here, small side, is to 21 long side, as 24 here is to Y here. So there's the components for that proportion. 18 is to 21 as 24 is to Y. Small triangle, large triangle, small triangle, large triangle. Cross multiply, divide, you get 18y is equal to 504, divide, you get 28. So now we have a 2 and a 28. Here's your 28, here's your 2. You want the entire perimeter of that large triangle. So again, revisiting the reason we need that 21 is to figure out our perimeter. 21 here, 24 here, and 14 here, because remember we found X is 2. So that whole side's a 14. Add them together, whole perimeter is 63. Pull back a little bit so you can see the entirety of that solution. Okay, moving on. If 2 triangles are similar, then what happens is you have similar proportions for figures that have altitudes, figures that have medians, and figures that have angle bisectors. Notice the 3 differences here. Altitude, they drop to 90 degrees. Look at your similar sides. 20 is to 6 as 15 is to X. Your corresponding sides in those figures. Same thing's going to happen if they have medians. Look at your corresponding sides. 24 and 16, X and 9. Look at the corresponding sides and parts in angle bisectors. 16 and 10, 18 and X. All of those corresponding sides are the exact setup for the problems. I'll pull back so you can see the whole figure there. 20 is to 6 as 15 is to X. Use cross products, cross multiply, divide, 4.5. Again, please be comfortable with getting fractional answers. Next one, even though it has medians, it's the exact same type of problem. 24 is to 16 as X is to 9. Cross multiply, divide, 13.5. And same thing yet again, even though they have angle bisectors this time, the setup is exactly the same. 16 is to 10 as 18 is to X. Cross multiply, divide, 11.25.